Hi stat students, let's go over your Unit 7 quiz review, sections 10.1 to 10.4. Make sure that you have your review in front of you, you're making note, and making sure all your answers are correct. Alright, Bon Air Elementary School has 300 students. The principal of the school thinks that the average IQ of students at Bon Air is at least 110. To prove her point, she administers an IQ test to 20 randomly selected students. Among the sample students, the average IQ is 108 with a standard deviation of 10. All right, we have a lot going on there, so let's see what's going on. So the principal of the school thinks that the average claim of IQ is at least 110. So if we were going like a null and an alternate goes, we're saying that the average IQ is 110, and she's claiming that it's more. So a type 1 error would be rejecting the null when the null is true. So the type 1 error would be claiming IQ scores are over 110 when in reality they are equal to 110 or even possibly less. Okay. A type 2 error is when we fail to reject the null when we actually should. So we claim IQ or average IQ is 110 when in reality it is actually more. Okay, for this next question, question B, this is actually pretty open-ended. You can choose any alpha level you want as long as you have justification. So for instance, if you claim a type 1 error is worse for whatever reason, then you better have an alpha level that is small, like 0.01. If you claim a type 2 error is worse, then you better have an alpha level 0.10. If you feel like there's really no major consequences either direction, and that's what you're going to claim and justify, then you can have alpha equals 0.05. This question, there's not really a right answer for this particular question because there's no life or death circumstances or any huge loss of money, I suppose. But right here, this justification, that's what really matters. So as long as you justify, then you're great. Even if you use alpha equals 0.05 with a justification, you're good. If you're like, you know what, I don't really see any huge consequences either way. So when in doubt, alpha equals 0.05, that's fine too. Just make sure you explain one way or the other, okay? So based off these results, should the principal accept or reject her original hypothesis? All right, let's do this. Step 1, is this categorical or numeric data? That's what I have to ask myself. And this is numeric data because when I'm asking, I'm like, what's your IQ? And they're like 110. So mu is the true average IQ at Bon Air. All right, we already wrote the null and alternate. That was helpful for us to figure out our type 1 and 2 error. It either is 110 or, it's greater like she claims. Step 4, let's check the conditions. Was the sample random? 20 randomly, so that's stated. B, all right, we have 3 options for normality when it comes to numeric data. Option 1 is it stated normal. The answer is no. Option 2, by the central limit theorem, is n greater than 30. That's no again. Option 3, if you have raw data, you can make a normality plot. No raw data, so normality condition has not been met, and it can't be met for this problem. All right. C, sigma is unknown because this value up here of 10, that's off of the sampled students of 20. So that would be S, not sigma. And D, 20 needs to be less than 10% of the population. For me, I'm going to use my alpha value from above. I'm using 0.05. Okay, this is going to be a t-test. Okay, step 7. Find that t-value. We came up with 108 minus 110 over s, which is 10, over the square root of n, which is 20. And this will give us a t-value of, 1 second, negative 0.8944. You only need to go 3 decimal places, so I'm going to take one of those 4s off. All right. Remember the steps, the signs need to match. So it's a probability of a just kidding, not a z-score, a t-score being greater than negative 0.894. TCDF, lower bound, negative 8.94, upper bound, something large, degrees of freedom, 19. Second vars, TCDF, negative 8.94. This is 0.808. This is much larger than any alpha value you would choose. So here we would fail to reject the null. All right, so let's move on to step number 9 with a p-value of 80.8%. The data suggests the true average IQ score at Bonneview Elementary. Bon Air, just kidding. Oh my gosh, I'm just making stuff up, you guys. I'm sick, I'm sorry. Bon Air Elementary is 110. Or less, potentially, honestly. Probably less, she's lying. All right. Cool. Next problem. A survey claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. To test this claim, a random sample of 1,200 doctors is obtained. Of these doctors, 871 indicate that they recommend aspirin. Is the claim accurate? Okay. Step 1. This is categorical data because we're saying, do you recommend aspirin, yes or no? So pi is and will always be the true proportion of doctors who recommend aspirin. Let's get some data off this problem really quick before we get going here. So right here, 9 out of 10 doctors recommend aspirin. This is what we're saying for all. Okay. Yeah, so this can be kind of confusing because it says a survey and then a sample. So this is a claim for all doctors nationally, let's say, and we want to test it versus our little sample. Okay, so N 1200, and P is 871 out of 1200. What's that? 871 out of 1200. 0.726. Okay. So, number 2 and 3. Okay. Is the claim accurate? So we can just say it's equal to 0.9 or it's not. All right, check the conditions. Is the sample random of 1,200 people? Stated. N, 1,200 times P, or pi, sorry, 0.9. That is greater than or equal to 10. 1,200 times 0.1, that's also greater than or equal to 10. And 1,200 is less than 10% of the population. Alpha level is given of 0.01, and this is a 1 prop z test. Z equals p minus pi over the square root pi 1 minus pi over n. Number 7, let's calculate that z-score. Z is p, 0.726, minus pi, 0.9, over the square root, 0.9 times 0.1 over 1,200. Let's find out what this is. All right, we got a pretty big z-score of 20.092. Okay, remember that this is negative, so we're looking less. So what's the probability of a z-score less than negative 20.092 multiplied by 2? I don't even need to do this in my calculator. I know this is 0. More than 20 standard deviations away, that's out of the question. Compared to alpha, that's less. We're rejecting. With the p-value of approximately 0, the data suggests the claim is not accurate. The true proportion of doctors who recommend aspirin is not 90%. All right, next one and last one. A nutritionist claims that ready-to-eat breakfast cereal has more than 100 calories per ounce. A random sample of 12 ready-to-eat cereals provided the following nutritional information. All right, does the data support the nutritionist claim? All right. So a nutritionist claims that ready-to-eat. All right, let's talk about this really quick. These are numbers, so this is going to be mean. We're talking about calories per ounce, true average amount of calories per ounce. All right, and this nutritionist is claiming that they have more than 100 calories. So we can start backwards and get to 100 calories. Next thing we need to do is we need to pause and put all of this data into list 1 of our calculator and run the one variable stats. So everyone pause, put all 12 values in your calculator and run the one variable stats for X bar and S. All right, we should get an X bar value X bar value of 100.940 and an S value of 7.702. Cool. All right, so now that data is in list 1. So let's come check our conditions down here. Step 4 is a sample random. It's stated. Step 2, is it normal? All right, we have no stated normality, n is less than 30, but we do have raw data. So now what you're going to do is on your calculator, you're going to hit second stat plot. You're going to tab down to type, and I'm going to just scroll to the side really quick. So to do this, you're going to hit second stat plot. Go to where it says type. There's 1, 2, 3, 4, 5, 6 little squares. It's this one here. Make sure it has the list where you just found all your data, your one variable stats. Hit graph. And if you don't see anything, remember, you always hit zoom 9. Okay, and then I'll draw up what this should look like. Okay, so what I got is I got something that looks like and what this means is the normality plot looks approximately linear. So since normality plot is approximately linear, then it's safe to say the data is approximately normal. Step C, sigma's unknown because we only have sample data. And step D, 12 is less than 10% of the population. Step 5, we can use alpha equals 0.05. Step 6, this is a t-test again. Alright, step 7, let's find that t-value. T equals 100.940 minus 100 over 7.702 divided by the square root of n, which is 12. Let's see what we get here. Alright, and the t-value I came up with is 0.423. Step 8, remember the symbols need to match. What's the probability of a t-value greater than 0.423? TCDF, 0.423. Upper bound something big like 1,000. And degrees of freedom here are 11. So let's see what we got with this. .340 greater than alpha. Fail to reject the null. So with a p-value of approximately 34%, the data suggests the true mean amount of calories per ounce is indeed 100 or possibly less. The nutritionist is wrong. Alright guys, hope you have a great day. See you later. Bye.